So everybody welcome. So far I can see the name list of participants. They all can speak Chinese, including Nishino-san. Actually, Nishino-san could speak better Chinese than I do. So if no one object, I would use Chinese for now, unless I can see other people coming in. Now we use English. All right, let me start. I give you some, some background information first before I answer the questions, because you have some of you provide some questions which I would be able to say a few words. In case I could not answer the question, I will pass the questions to Nishino-san, because he's a real expert. He had participated very deeply in the Kaguya mission. So this is the outline. I will just give you some introduction on this initiative by this Orbital Space. So I switch back to Chinese. 就是那个，我现在跟你讲个这个叫阿联酋哈，阿联酋的一个私人公司叫做 Orbital Space 的，很有趣的一个公司。他的一个 CEO。我们跟他接触过了，他说告诉我有这个 competition， 我觉得蛮有意思的，等一下会讲到它的内容是怎么样子。如果你们已经看过的话，那另外就是那个 other thing is about the mission scenarios, namely that some of you ask where would the lander the landing site be? I mean, we could only guess because we really don't know, but I think that we should try to guess where it would land at, because there are some boundary conditions of the mission that would more or less limiting the selection of landing sites. And then some of you should know that the temperature variation is very large, huge at the moon, day and night. But I just want to remind you. And then the radiation environment on the lunar surface. Some of you asked about that. And then remember, the proposal submission deadline, I think, is pretty close. So you better be careful if you are interested in submitting proposal. Firstly, it's about UAE itself. United Arab Emirates has a very, very rapidly expanding space program. And I think it's one of the up-and-coming space agency. You can see that it has started a Mars mission called HOPE with America, and still orbiting around Mars, getting very interesting data. And recently it has signed a contract with a company, iSpace in Japan, to send a rover to the moon. And the same rover, the same type rover, would be flown to the South Pole on the Chang'e 7 of China, Chang'e 7 mission of China. So it cooperates, UAE cooperates with America, with Japan, and with China. And is also talking to India about its low-cost launching vehicles. So it has a very large ambition. And I just found out that recently, I mean last year or so, the space agency of UAE announces that its next space mission would be to Venus and an asteroid landing. So it's just in a very short time span, it has spent rapidly. And Orbital Space is a private company, and I think that it has kind of trying to capitalize on the rapidly expanding space program of UAE, and that there are a number of activities proposed or organized by this organization. And one of them is the so-called experiment on the moon. The lander is to be launched in 2025. And as we know that it will be carried by a iSpace spacecraft. You'll see this. If you want to get more information, you should go to this website, and they will answer you. But then I remind you that we have recently invited the CEO of Orbital Space, Dr. Bassam Afeli, to give a talk introducing the company, its organization, and also this experiment. And if you're interested, please go to it's on YouTube. Please watch it, and you will get more information about it. Firstly, about the basic is about the constraint on the payload, and I think it's put somewhere on lander, I would say. I think that the iSpace is a company which offer space, to go to the moon. But of course, you have to pay some money, and so here, Orbital Space offered to the competition program project. The limitation is that it has to be like a cube. Space is a CubeSat, 1 U CubeSat kind of thing, and a total mass of 200 grams. So it's very light. So the idea is that you send ideas, and so far what I got is not very clear. Dr. Affiliate always talking about, oh, you just give me the ideas. We'll try to choose the best idea and work with you. And I think it's not that simple. I think you need to have do more work than just having a great idea. So the constraint is a 10 centimeter by 10 centimeter by 10 centimeter, and the volume might not be is perhaps sufficient for a small experiment, but then the total mass is small. It's 200 grams, and the power I have no information here, but I think you could consider about 1 watt on the order. And here's just what you get out of the competition. Join the competition that you do. If you're interested, and then you get into learning more about lunar science, and exciting, getting more imagination and curiosity, and get in touch with other people who are interested. Namely, that I already have seen that some of the questionnaires saying that one person asking, how can I find a partner, collaborator, to work on an experiment? And so if you, some of you if you're interested in joining, forming a team, could write to me, and I could send the information, contact information to each of you, and so you could talk about it. So that's one thing, that to have some brainstorming, and then other things, of course, that by doing so, you really, have the more or less obligation to learn more about the moon. And then there's several phases. Phase 1 is that the deadline for proposal is December 16th, and I don't have the the email address for you to send in the proposal, but you can find it out easily from looking at the Orbital Space website. But remember, the deadline is December 16, and then you have to send it to Orbital Space. All right, and you can see that there's a number of things you need to tell. You have to. There's a good way to learn how to plan a mission. That means why you want to do this. What is the science you want to do, and then what kind of technology you think you can you have innovation, and then asking your capabilities. Are you really good enough to do the job, or doesn't have to be good enough, but at least you have to describe yourself, right? And then your preparation in hardware and software, and then you need to have a timeline. So in space science, in space technology, everything is about a timeline. Start and ending milestones, and so on. And the budget, the other important thing, that how much you have to estimate how much you need. And then do you need to have you need to testing, you need to have a place to calibrate, and this kind of things. And then you have to add all the components of your experiment together and weight it and estimate how heavy that is, right? And whether the payload is larger than the limit of the volume, 10 centimeter by 10 centimeter by 10 centimeter, and all that. And next phase is that after you submit the proposal, I think they will have a panel of experts, and then they would choose 10 best ideas, top 10 ideas, and they would invite them to present, say virtually, maybe by online, in front of the panels, and then in order that they would choose the final winning idea. And I still have no clear idea that how they would support, if the best idea has to do a lot of testing and so on, and who's going to help them. So you might want to ask him, and then the winner then would have the payload on the spacecraft, on lander to the moon in 2025. So as simple as that. Now, so I want to tell you a bit, and I think that because UAE, the space agency there, has signed contract agreement with this company, private company in Japan, iSpace, for a rover. So I believe that they will follow the same track and using the lander. And there are two types of lander now. The series one, the first type is on the upper panels. You can see that one. You can also see the size, right? And also there's a rover on the upper right-hand corner. You see the rover there. And then now they have designed a new type, presumably larger. And then that's on the low panels. You can see also the ratio, of the size of the man. And this is what would be carrying some of the payloads that pay for space to the moon in 2025. And presumably this is the first private company to carry experiment to the moon. And this diagram shows you the comparison of the size of the Apollo lander. Of course, it carried the astronauts, right? So it's much bigger. And currently the iSpace lander, you can see the reduction in size. With the lunar environment, I want to remind you that this is a good way to learn about the moon and also about the Earth. There's on the left-hand side, the moon is circling around the Earth in the 28 days orbit. It goes in and out of the Earth magnetosphere. So sometimes it's in the solar wind. Most of the time, 2/3 of the time is in the solar wind. And 1/3 of the time is in the Earth magnetosphere. But then because the face of the moon have to connect to the orbital phase of the moon, of course. So in the Earth magnetosphere, there's a time we have full moon, right? And there's a time that where I think the communication, if you land, I think most likely you will be in this situation. And because if you land it on the new moon cases, even though there's a communication between the moon and Earth, but it's very cold on the moon, so it's not the best place, not the best time to send a lander there. And this is the model on the day-night temperature variation on the lunar surface. The red top one is at the equator. Yeah, so at the equator, at noon, the temperature could reach as high as 390 K, and that is about 130 centigrade. And as the sun goes down and the temperature drops rapidly, and then to the midnight, it goes down to minus 170 K. Yeah, so this is the temperature range you have to to be aware of. And usually, I think that without heater, your experiments would not be able, I mean, the lander perhaps also would not able to survive the night side passage because it's too cold. So if you look at the previous landing sites from different agencies, and you can see that there's Blue Stars, American one, and then they have a red stars, China, and then the red shackles from the former Soviet Union. So it's almost, everywhere, right? And you can say that. But however, those landers might have a different thermal control. Namely, they might have its own heater, so they could survive through the night. And as we know that the moon's orbit around the Earth in the orbital period of 28 days. So it's a half. I mean, the daytime is 14 days, right? And then the nighttime is 14 days. So basically, if you have no thermal control, you have the maximum. You have 14 days for your experiment. So it's not a lot. If you look at the regional agreement of the UAE, United Arab Emirates contract for shipping a rover to the moon by iSpace, and according to the news report, the landing site is the one a circle around there. Yeah, it's called in English called Lake of Dreams. I mean, it will land in March 2023, so it's just less than 6 months from now. So they will have a lander at there. And so if land there, I think I could tell you that that means what likely, because the shadow of the moon move from the left to right. So I think if you land at the limb on the right hand side, and the shadow just move closer and closer to you. So basically you could have at the maximum you have 14 days, right? And then but on the UAE rover on March 2023, you would perhaps have less than 14 days, and depending on whether the rover has a thermal control or not. If it doesn't, you will have very short time to. Also that because when the lander landed, there must be some checkout phase, and your experiment might need to check out. So that it means that it doesn't mean that you immediately could go into operation. So already there some time we have to spend on doing this kind of checkout. So the actual scientific operation time is even less. So you have to take that into account. And this is the radiation environment. Someone asked, and you can see that because the moon does not have an atmosphere, so it will be bombarded directly by the solar radiation, the photon, by the cosmic rays of energetic particles, and by solar wind. And so you can see that on the right hand side, which is the night side, so it says minus 170 degrees centigrade. Yeah. On the day side, it's very hot, extremely hot, 130 degrees C. So you need your experiment have to match the temperature range. Yeah, and I mean not the temperature range. I suppose you are not going to the night side anyway. So that's at least on the day side. If you go to the moon, you have a very high temperature. And then because it was bombarded by cosmic rays, so the moon is a kind of radiative in the sense that an astronaut on the moon, it will be even though if it's in a spacesuit, it would be constantly bombarded by galactic cosmic rays, which is very energetic photons, electrons, and from time to time, if the sun has storms, and you will be bombarded also by solar particle events, which are also energetic particles. And these are the primary radiation because they exist already beforehand. When they reach the ground, because the moon is not protected by an atmosphere, this particle, energy particle, would basically penetrate into the ground and interact with the lunar soil, and producing a nuclear reaction. And that way, it will also produce radiation, we call it secondary radiation. So you produce neutrons. Neutrons very penetrating. Yeah, so it's also not a good thing for astronauts. And gamma ray photons, also very penetrating, also not a good thing for astronauts. So the environment, the lunar environment, is quite radioactive. This even though it's only one side because it's a shielded one, so it's radiated by 2 pi, right? Not like in the free space you have 4 pi, but then on the ground, out of the ground, you have this secondary radiation. Yeah, so you also have to be there. But since your instrument will be there for only at most 14 days, so maybe that's not so bad. But it's a good thing to learn about it. So as far as I know, the first measurement of the radiation dosage on the lunar surface was done by the Chang'e 4 lander, and you can if you're interested, you could go look at this paper published in 2020. All right, it tells you some numbers. Since I'm not expert, so I don't know what does it mean. I mean, but people will be interested in comparing to the dosage, radioactive dosage that an astronaut would be able to tolerate, over a stretch of time. So those are important numbers. And the other thing is that if you are interested more about the so to say assembly, integration, and testing procedures, the requirements for lunar systems, I think there's a paper, useful paper that you can look at. It was published in 2016, and by the Canadian Space Agency. So you are welcome to look at it. And it has a kind of top level, description, so it would be good enough for you, for now. So this is what I have to say now, and then and I'm now switching to the question you have. All right, Munza, can you then show the list of questions? Now I first picked some questions, I know, and then in the middle of it, if you have questions, you could raise your hand, right, and just ask. You could ask me, of course, in Chinese, and if you like, you could also ask. I think if Nishida-san, I'm sorry, Nishino-san is there, you could also ask him in Chinese. All right. The first question is: will we go as far as South Pole or North Pole? So, and not getting into the hole, into the base, the bottom of a crater. So the answer is no. And I suppose that the lander would land at best at near the mid-latitude or equatorial region. So not a place where you could find water ice. And if you mean water ice. So another question, second question, do you think we will be able to easily go back and forth to the moon in the near future? Well, depending on what you mean by near future. If you say 10 years, so you can go back and forth to the moon not that easily. I suppose 10 years from now would be 2032, right? Already there should be the landing, I mean the landing, return of the astronaut. I don't know which country that might be, to the lunar surface. And then from then on, there would be continuous construction work, step by step, to build a research laboratory or base camp on the moon. And if you are interested, you could go check that the NASA has contract to SpaceX on the transportation system. They are using the Starship to go between from Earth to Moon and back. It's a huge system. Yeah, it carries can carry tens of astronauts, if not hundreds. So things might happen. If nothing bad happened in between, things could happen quite quickly from that point of view. My guess is that by 2040, you will have a small research lab somewhere, if not a couple places, for temporary residence of scientists or astronauts there, doing experiments or exploration. And the number 3 question, what are the measures taken just in case the lunar mission failed or had a technical problem during the flight in space? I think that's very bad. I mean that basically the mission would be discarded, isn't it? I mean that there's nothing to do anymore. I suppose. Then you must then find money again, to do the mission again. That's perhaps what you need to do. And this does happen, not that it's not the chance of this happening is not small. And you should take this, as a first try, right? And then you should take into account the risk and the possibility of failure, and then from then you learn things. You learn important things. Sometimes you learn more things from failure than from success, to some extent. And then also that this is not a one-step thing. If you're young, you're very interested, ambitious. You should think that, oh, this is just very beginning. You would go further and further and further and further, right? And number 4, what the benefits of lunar mission is if we don't want to live there. We don't want to live there. Of course, not everybody wants to live there, I suppose, because it's not a very civilized place, right? And then there are lots of restriction in life there. But then, so it's mostly lunar mission. I want to say this. This is from European Space Agency. Because European Space Agency is very interested in the moon, so and they are very careful in thinking things logically and planning things logically. And they said that there are 3 steps in the study of the moon. The first step is the study of the moon. Study of the moon is like what we are doing now for a long, long time. That we want to know the geology, the interior, the surface, yeah, and the environment of the moon. So it's the study of the moon, right? And then there's second phase is science on the moon. That means you step step foot on the moon, and you set up your laboratory, and there you start drawing, you start exploring, you start building up things, yeah, and there you're doing geology of the moon. The moon is interesting, important in the sense that because the moon formed almost at the same time, of the Earth. Therefore, it carries all the information that perhaps partly missing from the Earth. So the moon base is a museum, archaeological museum of the solar system formation. So from basic science, is very important for us to understand it, because it's just a part of Earth, you might say that. The second thing is that we go there to explore and to not just to explore, but also to mine. Yeah, that means that there's some very precious material on the moon. Would be useful, would be critical in supporting future exploration, deep space exploration, like water. Yeah, and which can be used for fuel for further deeper space exploration. And other thing is that once we are there, and then you go to the first phase, which is called science from the moon. Science from the moon is that there you could build scientific experiments, yeah, to study the universe, to study things that we have not been able to to consider, because the moon is a natural platform. So the moon turns out to be very useful. I mean, it's just that could very well be part of the human civilization 1,000 years from now on. So it's not to say that we don't want to live there. So do we have other questions, Mengzi? Liao-Yin, yeah. I'm not one of the viewer of the competition. Don't worry about it. Liao-Yin. Yeah, they must find some. I don't know. They have plenty of experts. I'm here just just curious about what they're doing, trying to learn more about it. Yeah, so that's what I'm doing. And then Wang Zhaoyu, the usage production of hydrogen or methane allowed. As long as you don't destroy the lander, I think you're allowed. I mean, am I right? Yeah. So there's a safety concern. You don't want to. Oh, I have 200 grams. How about I carry a 100 gram dynamite? They won't do. So therefore, they would check the. I mean, not orbital space, but I'm sure the ice space would check that question very very carefully. Yeah. And you ask Wang Zhaoyu, you ask, is purified protein allowed to get on board? What do you mean by purified protein? You want to do a biological experiment? I think you might be just making a clever remark. No, I don't know what you want to do. You want to put but they will spoil quickly unless you put in a tube, right? In test tube, and then what do you want to do a biological experiment? And then, well, if you have some idea, just do it. Just do it. I think that's an interesting thing. Try it, and then by thinking out loud, to yourself, then you might come to some interesting, better idea too, right? You're welcome to. Well, I do, but to avoid biological contamination, I have to use protein. I don't know what kind of experiment you're talking about, because usually we don't, when build a experiment, we put a telescope. Usually we don't touch protein, right? Yeah, there's no organic. We don't usually try to avoid organic material, even though you may have crews there, and the crews and so on, and they are, but still they are not strictly protein in that sense. Okay, let's continue with that. So the number 5 is the lander's location on the moon. I think I answered the question. Try to answer. I'm just guessing. Yeah, I'm just guessing that the being cautious, the ice space would be putting the spacecraft or the lander on the side, which in the area I showed you, where still a bright daylight, and that took a few hours and few days. I mean, 10 days or so, for the shadow to move in. Because once the shadow comes in, the temperature will drop to very low, yeah, and then basically everything will be gone, as far as I know, yeah. And I think this is a limitation for having an experiment on the lander, as I was told for now. And this is in Chinese. 在月球设立太空站所面临的辐射环境会到会。As said, even if you're talking about the Lunar Gateway space station, the Lunar Space Station, of course, the wall being bombarded by cosmic rays, of course, but it has the same problem, because the wall has material, so you will also have a nuclear reaction. So I would say that the lunar gateway will still be a emitter of secondary radiation, like neutrons, or even gamma ray, photons. But maybe to a lesser extent than on the lunar surface. So this is a question I cannot answer you immediately. Maybe I will pass it to Nishino-san. Nishino-san, are you there?
Yes, I'm here.
Can you ask the question? You read the sentence, right? You read the questions.
Question number 6.
Yes. 它是问在月球设立太空站所面临的辐射。
Actually, 在月球表面
in Chinese,
Okay. At the lunar surface, we have to take into account the effect or risk of dust, charged dust particles. It potentially must be harmful for human beings. So we have to take into account the risk of charged dust particles.
Yeah, we have not talked about the dust. And let me check. We have an expert on lunar dust. 许祥文，你在吗 Sean?
Yes, I'm here.
Can you answer the question? Say a few words about the lunar dust environment.
Right. I think the general consensus is that it could be harmful for any kind of exploration on the surface of the moon for various reasons. One is that the lunar dust is very abrasive. It's basically made of through the impact process. And so it has sharp edges. There are no other process to, round them up. So they could be very abrasive, either for mechanical joints, or they could be attached to, things that you don't want to be covered, like a radiator or optical devices. And through the landing of a lander, you also, of course, locked up a lot of regulars that if you have, sensitive instruments exposed, that may also be a concern. And so I think that's mostly people talk about the dust hazard on the lunar surface.
Yeah, that is another, and actually, the person who just spoke is the Dr. Xu Xiangwen, Song Xu, from University of Colorado, and he had given a talk on our online seminar. So you go there and take a look. We have a number of talks on the lunar dust environment on our mini moon seminar. So you're welcome to take a look. And I see on the chat box, Liao Yin answering, Wang Zhaoyu saying that I think you can check the guidelines of planetary protection. Yeah, I think for the moon, the planetary protection constraint is not that severe. Not like going to Titan, or not like going to Enceladus or Europa. So I mean, for the lunar dust and other things, if you have questions, please write to me or write to us. And we could find time, that maybe we would find an expert to give a talk again. Yeah, and the number 7 is why we have to go to the moon. I think I answered that earlier on the question number 4. Yeah, that once we get to the moon, we know how to. There are a lot of things we can do. It's more like finding a new continent, even though it's very dry. And you need to find water yourself. You don't want to find material to build things yourself. So that's very challenging, isn't it? I mean, that's why we go to difficult places to be creative, to know how to find solutions to overcome the new challenges. So number 8, does the workshop help participants to assemble a team? So write to her. If you want to contact any one of you here want to contact Tracy, I mean, which is Liao Yin, and if you don't have her contact address, just write to me or write to this TSU, okay? And then I don't know about Huang Zhaoyu, because if you're interested in forming a team, I think it's good to have a team, even though you may not know each other too well, but then by talking to each other, and then there's the spirit anyway. So the number 9, what's the priority of exploring the moon if humans want to build habitable base on it? It's not to exploring the moon, but really we call that the prospecting. Yeah, exploration means that you go to a new environment just to take pictures, make photos and collect stones and so on. But then on the moon, then you come to this another phase because you want to go there and stay, right? And you talk about humans want to build habitable base on it. So the most important priority is to prospecting, to look for 侦察, to try to find resources which could allow you to live, to build a self-contained biosystem. So you have to look for water. That's why now that there are several missions going to the South Pole to look for water. Yeah, water. And then to build infrastructure, because you don't carry things. You don't carry things from the Earth, to the moon to build houses, right? So you want to make use of the stuff right at the moon. So this we call that in situ resource utilization, ISRU. And ISRU means that you build factory to mine material on the lunar surface. Mainly basis is the lunar soil. That's what Dr. Strong-Shu just talked about, regoliths. Those are dust particles, and you extract from them. You extract metals like iron, magnesium, calcium, and you also extract oxygen. So half the lunar soil, because it's oxide, so it's 40% of the lunar soil composition is oxygen. So you do this. So one of the priority now in lunar technology science is to know how to make bricks without water. Yeah. And then some people will say that they're using biological microbial technology to make bricks. So it's very interesting. So those are opening, so to say, as you can see that this will open to open new grounds, in our science. So basically, the priority is to survive, to find food or find water, and then find things to build shelter, right? And where to best to stay, to avoid being bombarded by cosmic rays, yeah, and being bombarded by interplanetary dust particles, yeah. Okay, I think this number 10 is the final question. Is there possible synergy with the instruments that Taiwan may provide on the same lander? So I don't know whether I think you're referring to the experiments supported by the National Space Agency of Taiwan, the NSPO. I don't know whether they are on the same lander or not. I'm sure that I think that they are on the iSpace lander, yeah. But whether it's on and the time seems to be the same. And so I think from my point of view, it would be good that if those experiments selected to fly on the NSPO mission could talk among themselves to find synergy. There will be already a big step, and this question is not easy to answer, because this is basically we have to refer to the NSPO responsible persons. and in case some of them are listening or watching this program. But then I think that this is a good start, because and I can see that we have over 30 people. There must be about 20 some enthusiasts. Yeah, and then my advice is that keep going, right, and hope that some of you, at least 2 or 3 or 4 experiment proposal will come from Taiwan, and then send it submit it to the orbital space. And after that, keep going again, and try to improve among yourself. And then if you need any further help, we'll be happy to talk to you, right, as much as we can. And we cannot help you, we'll try to look for experts like Nishino-san or some other people to help you. Yeah, and then since you're all young, you could learn very quickly. I hope that basically we hope to use this opportunity to excite you, to get on the right path. And then afterward, and then next time when SPO announce the next opportunity to go to the moon, then you're ready, won't you? Yeah. Okay, that is about all I have now. And then okay, there's one question by Lin Jialong. On the other side moon is okay. He's asking, Lin Jialong, he's a PhD student here, and he's asking that would it be nice to have a telescope? Would the back side, the far side of the moon be a nice place to build an observatory? Actually, I think that, I would say that maybe 20 years from now, there would be a lot of observatories would be built on the far side of the moon, because there, indeed, as you said, that the radio, radio signal from the Earth would be blocked by the moon, so it's very quiet over there. And some astronomers even go to the extreme saying that when you build a radio telescope on the far side of the moon, only then will astronomy really start, because that allows you to really look very far away. Indeed, some experiments already, some space missions are already doing pilot study in how to build this kind of very long wavelength radio telescope on the far side of the moon. Those which are not those available are not accessible, on the ground of Earth because of atmospheric constraint. Okay, good. I think that if you have any further questions, you know where to send the question to, right? And then I would be happy to communicate with you. And I hope that, as I said, I hope that some of you would write proposals, submit proposals, and for that, good luck. Yeah, and remember the deadline is December 16th, and follow the instruction, step by step, as much as you could. And I think those are very good exercises, and those are things you cannot learn in classroom. Okay, thank you so much.